Hello geocachers, my name is Bob. Well, I'm just kidding. I am actually speaking to you with a computer-generated voice, so you can call me whatever you want. What is important is that a synthesized voice just like mine is actually being used in a gadget-type audio geocache. If you are interested in building this type of cache, I am going to explain how to make one. You don't necessarily need to use my voice. There are many computer-generated voices to choose from online. You can also use your own voice, or a friend's voice, whatever you decide. You can even add music. Now, I'm going to describe how you can build your own audio geocache. Let's begin with the most complicated, building a cache inside a payphone. The example we'll be looking at today is currently active, number GC8FQX9. I will also be discussing how to build other creative audio caches that are much more simple. You might be surprised at how basic this can be. Okay, let's dive into the really complicated one first, building a real talking payphone cache. All of the technical components can be found on Amazon. There is no need to go hunting for them. A list of the required parts will be provided at the end. The cost of the parts are competitive, but in any case will require modifications. The extent of these modifications entirely depends on how you intend to build your audio cache. For a payphone, the modifications will be extensive. But a very basic audio geocache is actually not very difficult and is surprisingly affordable. Let's begin. If you intend to use a payphone, you should be prepared for a challenge. Old payphones are available on eBay and sometimes Facebook Marketplace. But be aware, they are quite expensive, so be prepared for that. Specifically, you are looking for a black and chrome payphone with a single coin slot and a traditional keypad. Do not get the much more rare single-slot phones with a dial or the 3-slot dial phones. They will not work for this project. There are some absolute critical things that you need to know before buying a single-slot payphone. First, you need to have keys to open them. The locks on these phones are made by Medco. This company specializes in very high security locks. Even though payphones are no longer being used, most locksmiths will not make keys for them because of liability reasons. It may be possible to find a locksmith who will agree to simply open the phone, provided that the original lock is destroyed and no duplicate keys are made. You would need to research that locally. But if possible, try and find a phone that has original keys. Once opened, you can change out the locks with a conventional type that does not require special keys. There are 2 required keys needed for these phones. The first is the key that opens the upper technical portion of the phone. The other is the coin box door below. It is sometimes possible to find a phone with a key for the upper lock. Many phone companies use the same key for this lock in certain areas. The coin box keys, however, were all different. The chances of finding a lower coin box key is far less likely. If you do happen to find a phone with the keys, be sure to put them on a large key ring kept in a special place so that it doesn't get lost. In the case of this particular payphone, the key is kept on a long cable with a brightly painted block and kept in a special place held on with a clip. It is critical the keys don't get lost. Do whatever you need to do to keep them safe. Remember, they cannot be replaced. For peace of mind, you may just want to consider replacing the lock anyway so that you can make multiple keys. If you run out of options and must break into the phone by force, the lock must be drilled out. It will not be easy. These locks were made phenomenally harder and far more durable than even the best average locks. Expect the job to take several hours and break numerous drill bits before you get through it. One last note. In addition to the regular Medco locks, you will also require what is called a T-key. There is nothing special about them. They are cheap and easy to get on eBay. Once the main key is turned, the T-key is then used to release the latch. Okay, so assuming you have purchased a phone, you now have keys or have broken into the phone and replaced the locks, you are now ready to proceed building your payphone audio geocache. The original phone electronics are useless. They were intended to be connected to a special line specifically for payphones. They will not work for this project or even on a regular landline. To start, you will need to remove all of the original technical components. This includes the circuit board, the coin mechanism, and the ringer. You will need to reuse the original receiver cradle switch and the keypad, so leave those for now. In the case of this particular payphone, the actual cache is hidden in the compartment that was once the coin box. The lock was removed permanently and a plug inserted into the hole. A new coin box cover was made from 1/8-inch sheet steel. The edges were bent over and carefully shaped with a hammer to look like the original. A hinge was installed so that it will fall open when a solenoid latch releases it. A small cable was added to prevent the door from opening too far and damaging the hinges. An extended arm was added with a nylon sleeve which hooks on the retracting solenoid. Because the door is vertical, it needs some outward pressure to push it open. After some experimentation, a spring was found to be impractical. Instead, 2 neodymium magnets were used. They were oriented so that they opposed each other. They were attached with epoxy and fiberglass to securely hold them in place. When the door is closed, the opposing magnets provide the necessary force required to push the door open when the latch is released. Finally, all the screw holes were filled, and it was painted black to match the phone. If this is all done correctly and carefully, it looks almost original when the door is closed. The door is opened when the solenoid-activated latch is triggered by a digital combination lock. This is one of the most complicated parts of the entire project. The digital lock is obtainable on Amazon and presently about $25. It is an unbranded item from China, so there isn't much more to elaborate about it. The orientation and spacing of the digital lock keypad will not be compatible with the original payphone keypad. The digital code component and the keypad circuit board is all that will be used. The motorized latch portion will be discarded. You will need to rewire the new digital lock to the original phone keypad. This is where the fun begins. The physical contacts for the original keypad buttons do not simply open and close the circuit like a normal switch. There are carbon pads on the bottom of each key. The phone's original computer would measure the passive resistance and recognize which button was pressed. In this case, we need a positive open and closed switch for each button. You will need to disassemble the phone's keypad. You will need to obtain a circular punch the same diameter as the carbon contacts. Make solid contacts out of aluminum foil and then glue them on top of the original carbon contacts. The aluminum contacts will need to be securely attached and withstand the heat and cold of the elements, so you must use reliable glue. Quality epoxy will work well. Do not use ordinary white glue. It does not stick to non-porous surfaces reliably. Be sure there is no glue on the contact side of the foil. For most of the rest of this project, you will need to have excellent soldering skills. These skills are far more involved than what I can describe to you here today. Learning to solder well requires a lot of practice. If you do not have these skills or feel uncomfortable about it, you will need to find someone experienced in soldering to help you. The contacts on the original keypad were not connected with a neutral common connection. Originally, different resistance values for each button contact were measured to define each key. You will need to use a pointed scraper, or better yet, a Dremel tool with a cutting wheel, to grind away the physical trace connections for each button on the keypad circuit board. You will rewire it to make each key's contact switch independent. Make sure your tracer cuts are completely clear of the switch contact surfaces on each of the buttons. You will need to solder on new wiring to the cut traces, and if these interfere or damage the contacts, they will not work properly, if at all. Rather than getting involved with a common wire, just connect each key contact independently with its own pair of wires. If you are not well versed in electronic knowledge, this is the simplest way with the least questions, even if it means using redundant parallel connected wiring. Grind away some of the rear plastic housing to make room for your new wiring to run out below. Hot craft glue can be used to secure these wires to the board to protect them when you finish. You will need to periodically remove the upper detachable portion of the phone for maintenance and battery replacement. Therefore, you will want to use a cable from the keypad which can be disconnected. Any parallel computer cable can be used so long as it has at least 24 or more pins. That would allow 2 pins for every 2 wires connected to each button on the keypad, including the pound and star keys. The pound key is used to activate the lock once the code is entered. The star key is to clear previous entries. You will install and physically secure a female connector at both the detachable front and the inside of the phone. The cable will have two matching male connectors. You will solder your new keypad wiring to the female side and then securely install it using your own customized mounting. The same procedure will be done on the interior of the phone. You will only need to peel off the blister contacts from the keypad board. They are all on one plastic adhesive sheet. You can solder on your connections without any further modifications. In this example, a clear cover was made. This not only protects the wiring, but also makes it easy to check for loose connections. Solder your wiring directly to the board. Then route them to the female DB25 computer connector. Be certain your connections on each end match. In other words, be sure the wiring pair for the 5 key on the phone matches the 5 key on the digital lock. The wiring pair for the 6 key on the pad matches the 6 key on the digital lock, and so on. It is critical that you don't get any key connection on the phone crossed to the wrong key contact on the lock. You can confirm your connections are correct using the continuity function on a multimeter as you work. The activation for the digital lock is the 2 wires leading to the original latch motor. It is rated for only 5 volts at about a quarter amp. This is nowhere near enough to activate the solenoid latch that will open the cache. You will therefore need a relay. In this case, 2 relays were used with the coils connected in parallel. I will talk about the purpose of the second relay later. What you are looking for are sold under several brand names with similar specifications. You are looking for the T73 type board mount relay. What is important is that the operating voltage of the coil is 5 volts. Any higher and it will not work. Amazon typically sells these in multi-packs starting around $10. They also sell these pre-mounted on circuit boards with some additional components. These are intended to interface with electronic prototype microcomputers and should not be used for this project. Just get the bare-bones relays. You will also require a blank project circuit board to mount the relays on. They are sold in multi-packs of different sizes, typically of 10, and are very inexpensive. The holes on the board may not exactly fit the pins on the relay, so you might have to bend them slightly outward to fit. Once again, the coils for the relay will be attached to the wires from the discarded original digital latch motor. And again, there will be 2 of these relays with the coils connected in parallel so that they both activate together. For the switch connections, you will only be using the center pole on the normally open side. The center pin will be connected to the main bus from the battery, which we will discuss later. The power supply in this project will be a 12-volt sealed lead-acid battery. This is the type often used in emergency lighting or alarm systems. They are very common and relatively inexpensive. The latch solenoid being used in this payphone is actually rated at 6 volts, but it will be brute forced to work on the full 12 volts. It will only be activated for a brief moment, which is not enough time to damage the solenoid coil. This will provide a strong punch to positively be sure that the door will open. Some experimentation with the rated 6 volts had marginal results, but forcing the 12 volts worked perfectly. The solenoid latch is made by Uxel. It contains an internal spring which will need to be removed for this application. You will need to place the solenoid in a vise and tap out and pry back the housing in order to remove the coil for access to the spring. Make sure everything is perfectly aligned when reassembled so that it moves smoothly. The latch is installed horizontally, so gravity will be doing the work of resetting the lock instead of the spring. In this case, a bell was also installed and connected to the second relay mentioned earlier. This adds a surprising and welcome phone ring when the door is opened. It is optional, but it is a nice added feature. The bell, also on Amazon, is rated at 6 volts. It should not be forced to operate at 12 volts like the latch. You will require a simple DC power reduction converter. Unlike the latch solenoid, failure to reduce the power to 6 volts will overheat and damage the contacts on the reiterating bell switch. This is why the bell has its own separate relay. Technically, one relay could be used for both the latch and the bell, but isolating the bell to its own relay is not a big deal and will minimize the chances of a dual failure if one has a problem. The audio portion of the phone for the geocache message is provided by a simple MP3 message player. What is required here is a module that includes a USB connection to upload the audio file, a speaker output, a power input, and a switch to activate the recording. The one being used here is the Geocache recordable sound module found on Amazon. The module incorporates a built-in 1-watt amplifier, 8 megabytes of audio memory, and a simple processor, all contained on a single board. It also includes a small 8-ohm speaker and an activation switch. The Geocache module has connections for 2 voltages, 3.7 volts and 5 volts. We will be using the 5-volt connection in this application. Again, the power supply is a 12-volt sealed lead-acid rechargeable battery. This is far too high for the 5 volts needed for the sound module. The power for the digital lock is also 5 volts. To power these, you will need an adjustable regulated DC power converter. The device you require is called the LM2596 buck converter. This is a nicely designed module and is widely available. It is used both by hobbyists and developers as a standard low-voltage converter. It effectively works similarly to the 12 to 6-volt converter for the bell, except these are adjustable and intended for low-current purposes. The best part is that they have become so popular that they are actually sold in packs of 10 for about $20. And yes, it is available on Amazon. Connection for these converters is pretty self-explanatory. There is a marked DC supply input and a marked DC output. It is very important you do not get these backwards or it will immediately burn out. The connection polarity must also be correct. There is a single potentiometer screw for adjusting the desired output voltage. Do not connect the audio module or the digital lock before adjusting the voltage output on the DC converter first. For this, you will need to connect a voltmeter to the converter output. Turn the screw until it reads exactly 5 volts. Only then can you connect the digital lock and the audio module, or they will immediately burn out and you will need to start over. There is a possibility that the digital lock or the audio module could interfere with each other while sharing a single converter module. For this reason, 2 of these converter modules are being used, one for each. They are so inexpensive and easy to connect, there is no reason not to. There are several modes for playback. These are adjusted by leaving or removing a series of 3 resistors mounted on the board. Configurations include continuous playback, playback repeating, play once and stop, play once but then restart after disconnect, and so on. For the purpose of this payphone design, and probably most other geocache applications, you will want to remove the center resistor. In this configuration, the message will start when the receiver is picked up. When the message reaches the end, it will repeat unless the receiver is hung up. It will restart from the beginning when the receiver is lifted again, so that the geocacher can review the message at any time. The connections for the audio module are simple. The audio output goes to the phone receiver and the activation connection goes to the receiver switch. In this case, a 3-foot GX16 4-pin extension cable was used. 1/3 was cut off and connected to the sound module audio output and activation switch. A plastic wire clamp was used to secure it in the phone. The other 2/3 was connected to the receiver speaker and the receiver cradle switch. Again, it is secured with a plastic cable clamp. Like the keypad cable, it can now be easily disconnected to completely remove the front of the phone. The speaker in the phone's receiver is about 150 ohms and does not work the same way as the standard 8-ohm speaker included with the sound module. If you add an 8-ohm resistor to the original speaker, this will not resolve the problem. It may initially appear to be working, but if you attempt to use the original payphone speaker, it will not work reliably and the sound module will ultimately fail. The receiver will need to be disassembled and the speaker will be removed. The speaker that came with the sound module will replace it. The cover on the earpiece can be easily unscrewed. It will probably be locked in place with a small Allen screw, and this will have to be removed first. With the original speaker removed, make a tracing on a piece of 3/8" plywood. Then place the included sound module speaker in the middle and trace it as well. You will need to drill out the hole in 2 steps. First, make a 1 1/8" hole all the way through. Then make a 1 3/8" outer hole about 2/3 of the depth inside. Thus it is now a 2-step hole. Be aware these measurements may vary if the sound module manufacturer provides a slightly different speaker, so you need to verify the size. The speaker will drop inside the outer hole and rest in the smaller hole. Use a Dremel to shape the wood into a bowl. Then cut out the outer ring and file it to match your tracing. Finally, trim the edges smooth with the Dremel. The speaker is now ready to glue in place and install. You do not necessarily need to use the power tools shown. This can be made by hand, but it will take a lot longer. You can use hot craft glue to hold the speaker in place. Do not glue the wood sleeve into the phone, or you will not be able to remove it if there is a problem. Glue on some felt or leather to keep it from rattling inside, but make sure that none of it touches or covers the working surface of the speaker. Once all the connections are made, there is a potentiometer on the audio module that can be adjusted for the volume. An 8-circuit terminal block is being used as a main bus for power distribution from the battery to the latch, the relays, and the DC converter modules. The battery charging connection is also made here. A 7-amp fuse should be installed on the positive lead of the battery. If anything should go wrong with either the phone circuitry or the charging system, it will disconnect through the fuse before a disaster occurs, not excluding a fire. There is nothing worse than a chemical fire from a battery. A fuse is necessary. You should also block the coin slot internally so that the electronics are not damaged if a coin is deposited. When all modifications and connections are completed and the system has been tested, you will want to neatly mount the components inside the phone. Use insulators such as nylon posts or standoffs so that nothing touches anything it shouldn't. Using shrink tubing on connectors is advisable. Use zip ties to neatly and safely secure the wiring. The last part of this project is the charging of the battery. If there is line power available, a battery is technically not required. However, 12 volts will be needed regardless to power the solenoid and should have at least 6 amps. For this reason, using a battery would still be best. This would guarantee a clean, consistent, and correct power supply. To keep it charged with line power, you will need a small 12-volt trickle charger. Inexpensive chargers like this are available at, you guessed it, Amazon. If your payphone will be located in an outside or remote location without available line power, you will need 2 additional components to keep the battery charged. The first is a 12-volt solar panel. These are often rated at around 13 volts, which is fine. These are available for trickle charging batteries and RVs, although you will only need a very small one. One rated at about 25 watts will be fine. The other part required is a charging regulator. Just like a line charger, if the battery is allowed to continuously charge at a high enough amperage, it will ruin it in a short amount of time. Starting around $50, there are kits available that include both the solar panel and the regulator. It does not need to be an expensive system. It only needs to trickle charge a 7-amp battery in a Geocache. Okay, now that we have discussed how to build a payphone audio geocache, let's look at some less complicated examples. This could easily work for any number of creative designs. First, it does not necessarily require a digital lock. The digital lock is only to add a puzzle element to the cache, which must be solved before proceeding. As an alternative, you could build a similar cache using a regular landline phone. If you do decide to use a digital lock, it can open a door in an attached box instead. Like the payphone, the keypad can be used to unlock the cache. Mount the phone to the cache box, then route the wiring the same way discussed earlier. If you want to do something even less complicated, you can omit the digital lock and have an audio message only. The message will provide instructions or clues for the cacher, leading them to another location as a multi-cache. The procedure for building an audio cache with a regular phone is exactly the same. Here is an example. When the geocacher picks up this phone, they will hear a message explaining what they will need to do next. The keypad is inactive. There is only an audio message. Nevertheless, it adds an exciting element that is not normally found on a geocache. In later phones made by independent manufacturers after 1984, many receiver speakers were more conventional. Test the speaker impedance with a multimeter. If it measures between 2 and 8 ohms, you probably won't need to replace the speaker with the one that came with the sound module. Look for a later model landline phone, and the chances are much better that you will be able to use the original phone speaker as it is. Actually, you do not need a phone at all to make an audio cache. For example, your cache can play a message when a hidden door is opened, an object is lifted, a string is pulled, or whatever. Even just a disguised button pressed by the cacher. For any design that only requires the audio module, you wouldn't even need a large rechargeable battery. Just install a battery holder for 2 size C or D batteries connected to the 3.7 volt power input instead of the 5 volt. Change the batteries periodically as needed. Even if the cache is highly active, large disposable batteries will probably last well over a year before needing replacement. Be aware, however, if your cache is located in an environment exposed to extreme high or low temperatures, the batteries will likely have to be replaced more often. Make sure the electronics are sealed in such a way that they are safe from the elements or insects. Here is an example of a simple audio geocache built inside of an ammo can. A switch is attached to the side so that when the lid is open, the message begins to play. A false bottom has been installed hiding the sound module and batteries below. The speaker is mounted in the bottom. This is the first stage of a multi-cache where the cacher is provided audio clues to find the second stage. The fun thing about a cache like this is that the clues can be actual sounds such as animals or music clips. When the sounds are put together, the cacher can figure out where they should go for the next stage. Because ammo cans are weatherproof, this cache can be hidden in the traditional manner. Audio caches are very rare, and creating more of them would be highly welcome. The creative possibilities are nearly endless. If you want to be a real geocache rockstar, consider building an audio cache. Oh, and if you love my awesome generated voice, I would be flattered if you used me. You can find me and many other voices at naturalreaders.com. There are also several other websites that offer excellent computer-generated voices as well. Except Amazon, voices is the one thing they do not sell. Have fun, and remember, whatever you do, just keep on geocaching.